Okay, so now we go on to ethers. So ethers are two alkyl groups bound to an oxygen atom, and they can be classified as symmetric or asymmetric or cyclic. Okay, and for symmetric, the two alkyl groups connected to the oxygen are identical, while for asymmetric, they are not identical, and for cyclic, the two alkyl groups connect to form a cyclic compound. So let's learn how to name them. So for linear ethers, we have to name them as substituents. That is because ethers have a lower priority than alkanes. Okay, so in this case, our priority functional group is the alkane. So we identified then the parent chain. In this case, we have cyclopentane. Okay, and then we identify the substituents. Okay, so how do we name linear ether substituents? We use the prefix alkoxy. And if it's in a complex substituent, we use alkyl oxy, separated by parentheses. Okay, so in this case, we only have a simple alkene, a simple ether, okay, with one carbon. So this alk part of alkoxy would be the prefix denoting the number of carbons. So one carbon, meth. Okay, and so this meth is connected to an oxygen group that it connects to the parent chain. So this is our ether, meth, and then we add oxy. Okay, so that is our substituent. So we have methoxy and then our alkyl halide chloro. And then we do locant numbering. Okay, using the order of alphabetization in this case. So 1, 2, 3, 4, 5. Chloro gets the lower number, and then methoxy number 2. Okay, then we assemble the name. We get 1 chloro, 2 methoxy. Okay, cyclopentane. So at position 2, we have the ether methoxy. Okay, so ethers have common names as well. The system depends if it's symmetric or asymmetric. If it is symmetric, name it by using the prefix di and then the alkyl groups that are connected to the oxygen, and then adding a space, add ether in the end. So it's a two-word name. So diethyl ether, because there are two ethyl groups, ethyl and ethyl, two ethyl groups, ether. Okay. For asymmetric, we name it as alkyl and then alkyl. Okay, this is separated by a space. Okay, and then ether. And we typically arrange the two alkyl names in alphabetic order, but there are some exceptions to this. For example, methyl tert-butyl ether, which is also abbreviated as MTBE. Okay, so in this compound we have methyl and then we have tert-butyl. Okay, so we now go on to our first cyclic ether, which is the epoxide. So epoxides are the smallest cyclic ether, comprised of a 3-membered ring with 1 oxygen atom. They are highly reactive and they are typically used when we form epoxy resins. Okay, so you may encounter them in resins or in adhesives. And there are 3 systematic ways of naming epoxides: the oxirane system, the epoxy system, and the alkene oxide system. The oxirane system is the preferred IUPAC method. So for the oxirane system, what we do is we name the epoxide as a substituted oxirane. Okay, here is our oxirane group. And this becomes our parent chain. Okay. And when we do the numbering of an oxirane group, we always start number 1 at the oxygen atom. And then we can proceed in any direction, whether clockwise or counterclockwise, depending on the substituents present on the carbon atoms of the oxirane. Okay. So in this case, we chose number 2 on this side because there are more substituents. There are 2 on this carbon atom. While on the other side, there is only 1 substituent connecting to this carbon. Okay. So at position 2, we have an ethyl group. At position 2, we have methyl group as well. And then at position 3, we have a complex substituent, 2-methyl prop-1-enyl. We end the name with our parent name, oxirane. Okay. Now for the epoxy system, we instead name the epoxide as a substituent. Okay. A substituent that has a lower priority than alkenes and alkanes. Okay. And in this case, we use both locant numbers to label it. So taking a look here, if the epoxide is not the highest priority, we now give the alkene the highest priority. There are 7 carbon atoms that connect to this alkene, and so we use hept-in. At position 2, we have the alkene, hept-2-in. At positions 2 and 5, okay, we have 2 methyl groups, dimethyl. And at position 4 and 5, we have an epoxy. Okay, so again, this is different from alkenes in that when naming epoxy groups, we have to note which 2 atoms it connects to. Okay, so we use the prefix epoxy. Okay, now for the alkene oxide system. Okay, so this is quite different because we name the epoxide as an alkene, okay, in equal footing to an alkene. What we do is we imagine that this epoxide is an alkene with no particular stereochemistry, okay, and then we add the word oxide at the end to denote that that alkene is an epoxide. Okay, so in this case, we have the same compound. At positions 2 and 4, we have the alkene, 2 alkenes. Okay, because this is our imagined alkene. At position 2 and 5, we have 2 methyl groups. Okay, 7 carbons, hept-2,4-diene. Then we add a second word, separated by a space, oxide at the end, to denote that one of these alkenes is an epoxide. Okay? But you can see where this becomes confusing, because what if the other alkene is the epoxide? So it becomes ambiguous. Okay, so this is not commonly used, or this is only commonly used when we have simple epoxides. So to illustrate this example, we have here a structure that has the same name to the example we've shown above. However, the epoxide is on the other alkene in this instance. Okay, so as you can see, it becomes confusing. So this is for the alkene oxide system. Here are some cyclic saturated ethers. So we started with epoxides, or our oxyrane ring, and then we continue up onto oxetane, oxalane, oxane, oxapane, and oxocane. No need to memorize these. However, it's important to note that when we name them using the oxyrane method, we'll do the same when naming them by setting number 1 at the oxygen atom. So just in case you encounter them, number 1 always starts at the oxygen atom. Here are some cyclic unsaturated ethers, and they can be used with substitution. Okay, so we have furan and pyran. These are also known as these are also common solvents in organic chemistry. So we set number 1 at the oxygen atom, similar to the saturated cyclic ethers. And then here's our unique benzene ether containing benzene called anisole. Anisole is an accepted name, however, it can only be used without substitution. So you cannot connect anything to it and still retain anisole as a name. To be safe, you can use methoxybenzene. Okay, so let's do some exercises. So provide the systematic name based on the structure. For ethers, what we do is we look for the longest alkyl chain on each side of the ether. Okay, so we choose which one has the longest chain. In this case, we have two choices. We have a methane on one side on the left and an ethane on the right. And so we choose this. Okay, because this is longer, we have an ethane group here. And then we look at the substituent ether. We have here a methyl group, so we use meth, and then we add the oxygen connection, oxy. Okay, so when we construct the name, methoxy ethane. Okay, so when you look, methoxy ethane. Okay, we move on to the next one, which has, okay, we have an ethane group here and we have a propane group here. So we have 3 carbons here. This is the longest chain. We have a propane group. Okay. And on the other side, we have our substituent, which is, or which has 2 carbons. So it's an S, and then we add the oxygen group, oxy. So when you write the name, S-oxy. Okay, let's not forget, since we have a propane group, there would be ambiguity if we didn't add locant numbers. So we put 1, 2, and 3. So at this position we have, at position 1, we have ethoxy propane. And to confirm that, we have 1-ethoxy propane. Okay, so for number 3, we have a symmetric, we have a symmetric ether, and we have a cyclic compound on each side. So we just choose one, and then we form the parent name. So 1, 2, 3, 4, and 5. Okay, so we have cyclopentane. Okay, and then we select this whole portion as our substituent, and we have here a cyclopentane as well. Okay, so we have cyclopentyl. Okay, since it's quite a large, since it's cyclic, we will now be using alkyl oxy instead of alkoxy. Okay, cyclopentyl oxy. Okay, and then we separate it in parentheses. Okay, in order to whenever we use yl oxy, we have to separate it in parentheses. Okay, so we have cyclopentyl oxy, cyclopentane. Okay, let's move on to number 4. We have here an oxyrane. Okay, we'll be using the oxyrane system because it's the preferred method. Oxyrane. Okay, and then we have a substituent here, which is a methyl group. Okay, we have a methyl group. Okay, when we do the numbering, we always start with 1 for our oxygen, and then 2 for the carbon with substituents, and then 3. Okay, and then when we form the name, we have 2-methyl oxyrane. Okay, so when we look at the name, 2-methyl oxyrane. And here are the other names from the other methods of naming epoxides. So we have 1,2-epoxypropane and propene oxide. Okay, now number 5. Okay, we have 2 benzene rings, and one of them has a methyl group. And so remember the rule that we have to choose the parent chain which has more simple substituents. So we have to choose this benzene ring as opposed to the other one. If we chose this, we would have gotten a large complex substituent, and that wouldn't be desirable. Okay, and then we name our substituents. We have here a methyl group. Oh, again, the parent name is benzene. Okay, and we have here, okay, we have a benzene ring as a substituent. And when we have benzene as a substituent, we have to use phenyl. Okay, however, since phenyl is already defined as a simple ether, okay, as a simple ether substituent, we don't need to add phenyl oxy, rather we can use phenoxy. Okay, okay, so when we start naming, we first do numbering. Okay, M before P, 1, 2, and then 3. So when we form the name, we name it as 1-methyl (3-phenoxy) benzene. Okay, so we have 1-methyl 3-phenoxy benzene. Okay, for number 6, lastly, we have 3 different alkyl groups. So how will we choose? Well, always choose the longest alkyl group. Even if it's nested between 2 ethers, we always look for the longest alkyl group. In this case, we have ethane. Okay, and we have a large complex ether substituent. Okay, and within that, we also have a smaller ether substituent. So that's the nesting of our ethers. Okay, and then we name it. So we have methyl here connected by oxygen, a methoxy group. Okay, and that methoxy group is connected by another methoxy group. And so this comprises a complex substituent, so we have to close it in parentheses. But since we used methoxy, not methyloxy, we do not need to separate the inner substituent with parentheses. So we can write this as methoxy ethane. Okay, so methoxy ethane. Okay, so now we go on to sulfides, which are also known as thioethers. And these sulfides are two alkyl groups bound to a sulfur atom, and they may also be classified in the similar manner as ethers, as symmetric, asymmetric, and cyclic. So here's an example. We have ethyl thioethane. So we have two ethyl groups connected to the sulfur atom. So let's learn how to name them. So for sulfides, we name them much the same as ethers. And what we first do is we first determine the priority functional group. In this case, sulfides are still lower in the priority against alkanes, and so the priority functional group is our alkane. We identify the parent chain. We have cyclopentane, and then we establish the substituents. Okay, so when naming sulfide substituents, we name it using the prefix alkyl thio. Okay, so the alkyl group being the alkyl group connecting to the sulfur group. So we have here one carbon, methyl, and then we have one sulfur atom connection, methyl thio. Okay, and then here we have chloro. So let's define those. We have methyl thio and chloro. Now we do locant numbering, and since we do this in a cyclic parent chain, and we must use alphabetization as our basis, and so we give number 1 to chloro, number 2 to methyl thio. And so when we assemble the name, we have 1 chloro 2 methyl thio cyclopentane. Okay, so sulfides also have common names, and much like ethers, they have symmetric and asymmetric methods for naming sulfides. For symmetric sulfides, we do the same, two words using the alkyl group that's connected, and separating with a space, we add sulfide. So here we have two ethyl groups, and so we name it diethyl sulfide. For the asymmetric, we prefix it with alkyl space sulfide. Okay, so we have an alkyl group here. This is tert-butyl, and then this is methyl. So we have methyl tert-butyl sulfide. Okay, so the arrangement of the alkyl names are mostly trivial, but commonly they use alphabetic order. And so we also have sulfides with which are cyclic, okay, and they are saturated. And these can be used with substitution, so you can connect substituents to them. But much like cyclic saturated ethers, you always set number 1 at the sulfur atom. So we have thiarene, thiatane, thiolane. And if you'll notice a pattern, if you go back to the ethers, cyclic ethers, you'll notice that they only differ in their names from the prefix. So instead of using oxy, they're using thi. Okay, so that just distinguishes these two saturated sulfides from saturated ethers. Here are some cyclic unsaturated sulfides. We have thiophene and thiopyran. So their counterparts are furan and pyran in cyclic unsaturated ethers. They can also be used with substitution as long as you set the number 1 at the sulfur atom. And so likewise, we also have a counterpart of anisole from the ethers, thioanisole, having a methyl thio group, okay, which can only be used without substitution. Okay, so let's do some exercises. So let's try this in a similar way. Similar to the ethers, we will look at the 2 alkyl groups connected to this sulfur atom and look for the longest chain. Here we have 2 carbons, so we have an ethane. Okay, and now let's look at the substituent. We have methyl. Okay, we have 1 carbon here connected by a sulfur atom, methyl thio. And so the name of this compound is methyl thioethane. Okay, so that's methyl thioethane. Okay, let's look at the next one. We have 1, 2, 3 as our longest chain. Okay, so this is a propane. Okay, now let's look at the substituent. We have 2 carbons here, ethyl, and then connected by a sulfur atom, thio. Okay, so we have ethyl, thio, propane. Okay, let's not forget, since we have a propane group, 3 carbons, we have to define the locant numbering. So we have 1, 2, and 3. So at position 2, or at position 1, okay, we have the ethyl thio substituent. Okay, so let's see. Okay, 1 ethyl thio propane. Okay, let's go to the next. So here we have 2 equal alkyl groups. So this is asymmetric sulfide, and so we have 1, 2, 3, 4, 5 carbons, cyclopentane. And then let's look at the substituent. We have here 5 carbons. Okay, 5 carbons, cyclopentyl, okay, and then connected by a sulfur atom, cyclopentyl thio. Okay, so we consider this once we're using cyclopentyl, we have to consider this as a complex substituent, and so we will be enclosing it in parentheses. So when we name this cyclopentyl thio cyclopentane. Okay, there we go. Cyclopentyl thio cyclopentane. Okay. Number 4. Okay. So we have here a cyclic sulfide. If you recall, we can only actually use the cyirane or oxirane method in naming a cyclic sulfide or a cyclic sulfur epoxide like this. And so, let's determine the parent name. Okay, so here we have a 3-membered ring with 1 sulfur atom comprising the ring. And so, instead of using oxirane, okay, we don't use oxy, but we use thiirane, Thi-irane. Okay, so thiirane, we always set number 1 at the sulfur atom and number 2 at the nearest substituent, which we have a methyl group. Okay, so when we assemble the name, we have 2-methyl thiirane. Okay, let's see. 2-methyl thiirane. Okay. Let's go to the next one. Okay. Same as the ethers, we have a benzene ring here. Okay, so we have benzene. And then we have a methyl group. And then here, okay, we have a phenyl group, a benzene ring as a substituent, phenyl. And then we have a sulfur atom connecting it. So phenyl thio. Okay, and we do the numbering. Okay. LMNOP, we start with M. 1, 2, and then 3. 1-methyl. Okay. 3 phenyl thio. Benzene. Okay. Oh, I think it's obscured. Okay, 1-methyl, 3 phenyl thio. Okay, I forgot the parentheses. Okay, once we use il, 3 phenyl thio benzene. Okay, so you can confirm that in our slides. Okay. Okay, let's go to the next one. The longest chain, 1, 2, ethane. Okay. And then first layer, we have an methyl thio, methyl connecting to a sulfur group thio, and then within it we have another group, methyl thio. Okay, and since we're using nested substituents, we'll be adding parentheses on each one. Okay, so when we assemble it, it should be 2 parentheses, methyl thio, Methyl thio. Ethane. Okay, let's see. Okay, methyl thio, ethane.